Hello everyone and welcome to today's PortSwigginar on the topic of Burp Collaborator and Burp Suite Enterprise Edition. So before we get going, we'll give some introductions from the team. So I'm Hannah O'Malley. I'm part of the Enterprise Advocate team here at PortSwigger. So my role is to work with our trialists and customers to ensure that they're getting the required support to evaluate or procure Burp Suite Enterprise Edition. I'll pass over to Alex.
Yeah, hey folks, my name's Alex. I work in the technical support team. So as well as day-to-day support for our customers on both professional and enterprise products, we help customers onboard with trials, POCs, etc. And I'll be taking us through the demo today. I'll pass over to Rik.
Hi, yes, I'm Rik. I'm a developer here at PortSwigger. I typically work on desktop Burp, so Pro and Community. And today I'll be talking about Burp Collaborator.
Brilliant, thank you, Alex and Rik. So we do also have James, Adam, Sophie and Maya in the background today. They'll be managing the Q&A facility in the Zoom toolbar. So please use this to ask any questions you have during the session. We will try and respond to them as quickly as we can, but if we do miss any, don't worry, as we will be following up after this session with any answers that we may have missed. Brilliant, so during this session, we'll have a quick recap of our products, so Burp Suite Professional and Burp Suite Enterprise Edition, and how they work hand in hand. We'll then be passing over to Rik, who will be covering what Burp Collaborator and OAST is and what problem they solve. Following that, we'll touch on our licensing model, which leads us nicely into the product overview. So this will feature deployment options, how to get scanning quickly, integrations with CI/CD pipelines and issue tracking tools, and our new recorded login replay feature. So then we will then be rounding off this webinar with a rundown of what's left of our 2022 roadmap. Thank you, Alex. So on the screen here, you can see our Burp Suite products, but today I'll be touching on our two core paid products, which are utilised by over 70,000 customers worldwide. So there is Burp Professional, which will be on your right, and I'm sure many of you will be familiar with Burp Professional or even use it. And it's our manual penetration testing toolkit with features such as proxy, intruder, and repeater. We then also have Burp Suite Enterprise Edition, which you can see on our left, and this is our automated DAS scanner. And this allows you to schedule those automated recurring scans and integrate into your CI/CD pipeline. So that will allow you to scale your security scanning across your entire web application portfolio. So at the heart of both Burp Professional and Enterprise sits Burp Scanner, which is great because Burp Scanner uses PortSwigger's world-leading research to help you find a wide range of vulnerabilities in web applications automatically. But the main reason why we wanted to highlight the key differences between our products is that it's often thought that Burp Suite Professional and Burp Suite Enterprise Edition are a tiered product set, when in fact they're designed to be used to complement one another. You can utilise Burp Suite Enterprise Edition to scale your security scanning through scheduling those automated and recurring scans, but then use Burp Suite Professional to manually dig deeper into the results that Burp Suite Enterprise Edition generates. But in fact, the majority of our Burp Suite Enterprise Edition customers also use Burp Suite Professional. However, if you do need any further clarification on that, please feel free to ask the team some questions. Just drop them in the Q&A box and they'll be happy to answer them. But now I'll be passing over to Rik.
Thank you, Hannah. So yes, I'm Rik, as I said a moment ago. I'm a developer here, and one of the things I get to work on is Burp Collaborator, and I'm really pleased to talk to you today about the Collaborator and out-of-band application security testing, or OAST. So probably the best place to start is, what is OAST? What's the problem that we're trying to solve with it, and with the Collaborator in particular? So the best place to start with this is to look at how we traditionally look for security vulnerabilities within our applications. So we have some target, we have a client, and the client sends requests to the target, we receive responses, and then based on payloads we put in our requests and what we see in the response directly or in time information, we then infer the presence of particular vulnerabilities. So that's great. That obviously works really well for a large number of situations, and people do that manually, and automated scanners like Burp Scanner will also do the same thing. However, there's another kind of category of vulnerabilities where this approach doesn't work for us. So I'll call these out-of-band or vulnerabilities. So these are situations where there's any kind of asynchronicity. That's one example here. So we send a request, the tainted data is passed off to some external thread, process, or system. The response is returned, and then this payload is then processed unsafely by some system. So obviously this approach of looking at the response won't work for this kind of situation. And there are others. So stored issues, for example, where we're not aware of the retrieval point, would be another one. So there's a whole area of hidden attack surface where payloads within our requests are potentially ending up triggering vulnerable behavior, but yet we have no visibility of this on the responses that our clients send in. And this is really the problem we want to try and address with OAST. So our premise is we want to augment our traditional testing using an OAST methodology. Okay, so that all sounds great, but how can we do this? How can we find vulnerabilities in systems where we have no direct visibility of them, or even we might not even know their existence? So obviously for this to work, we have to have some taint path. There has to be some way we can send data in our request, which is then being taken and processed in some unsafe fashion by a vulnerable server. So if we can spin up a server which we control, so I'll just call it a listening server for now, and we'll build on this. And then if we can construct our payloads in such a fashion that we can induce a network interaction with that server, then we potentially learn a relatively large amount of information. So we learn of the existence of the server itself, so we'll get its IP address. This may or may not be the server we're interacting with directly with our client. We'll get the taint path, so we'll learn the insertion point. And then depending on the nature of the interaction, we learn more details from that. So for example, if it's an HTTP request, there may be a user agent, which then tells us more about either the software stack or the server itself. Okay, that all sounds great, but how can we go about triggering these network interactions and exposing these taint paths from systems within this hidden zone? Well, obviously that's going to be heavily dependent on the nature of the vulnerability. So how the vulnerable server is processing our data unsafely. But just to give you a few examples, we could put a domain name in a referrer header. So you can imagine this might be harvested by some system and then processed for analytical purposes. If we've got some kind of asynchronous blind command injection, we might want to induce a DNS lookup using a payload like this, or a fairly textbook XMT kind of vulnerability. So one of the things all these example payloads have in common is they all use a fully qualified domain name, and that's important because that will trigger a DNS lookup providing the domain isn't in a cache anywhere. So building on that a little bit more, we want to ensure that obviously the domain we're going to use to trigger this network interaction isn't in a cache. And we also want to be able to unambiguously define the taint path. So the path from the data we're sending in back to the interaction we receive on our server. So in order to do both of these things, we use one-time use subdomains. So carrying on with the example of a referrer header, we might place a collaborator payload like this in the referrer header. And this has this one-time use subdomain. It's sent to some system, which then does some interaction with it. So we're going to trigger a DNS lookup to find out where this server is. This isn't a cache because there's a degree of randomness in this identifier. Our DNS server is a little bit kind of special, really. So in addition to understanding the details of DNS protocol, it also recognizes these one-time use identifiers. And if it sees any of them, it caches the details of this interaction before responding with the IP address of the server itself. And this is key because it then means any subsequent network traffic then comes back to our DNS server. So for example, if the referrer header has been used to do an HTTP GET, we'll send the initial request for the A or quad A record for the IP address, and then we'll use the IP address to make the HTTP request, and then the server can then learn more details about the vulnerable server from the HTTP request. So then at a later date, Burp can come along and say, hey, do you know anything about this subdomain? And then, assuming the interactions occurred, we can then retrieve the details of that from our server. And this is really at a high level how the collaborator works. So we're now in a position to say, what is the Burp Collaborator? Well, it is this magic server that I've just been talking about. So it sits there passively listening, never initiates any connections, it just listens for requests. And these requests come in two flavors. We have the ones from vulnerable servers, which tell us about the interactions. So this collaborator has to understand DNS, because that's key to how this trick works. HTTP and SMTP protocol implementations then allow us to capture the details of any requests and conversations from them. And also they facilitate a couple of scan checks. So a vulnerable server comes along, it's received one of these one-time use identifiers within some payload, it performs some unsafe operation which then induces a DNS request and then optionally an HTTP or SMTP request. So these then come to the collaborator. We recognize these one-time use identifiers, we put them in our cache. Then the collaborator has a second interface, which is then used by Burp to come along and then retrieve the details of any interactions which have resulted from payloads that it generated. So this is really very much a conceptual view of the collaborator. However, architecturally, if you run, it's not amazingly dissimilar from a private collaborator instance if you run one of those. So this is effectively what the collaborator is. It's a stub DNS, HTTP and SMTP server, which recognizes these one-time use identifiers, caches the resulting interactions, and then allows Burp to come along and retrieve the details of any interactions relating to payloads that it has generated. Okay, so hopefully this all sounds great, and you're thinking, how can I use Burp Collaborator? This sounds fantastic. Well, the answer to that is, if you're an existing pro or enterprise user, then you almost certainly already are using the collaborator. And that's because by default, the collaborator is used heavily by the scanner, and by default, both the OAST payloads are enabled. So obviously you can configure this. The scanner is highly configurable, so you can switch off the OAST payloads if you have the need to do that. The scanner also uses the public collaborator by default. So this is an instance of the collaborator which we run at PortSwigginar for pro and enterprise users. So again, if you need to, you can run your own private collaborator. So for example, your systems might run a closed network, so you have to use your own instance. That's absolutely fine. So there's no additional licensing cost around either using the public or the private collaborator. If you're a Burp Pro Enterprise license, then you're good to go. For reasons which are hopefully now apparent, for a private collaborator, you will need a domain for which the collaborator server can be authoritative, and you also need wildcard TLS certs. Anyway, our support can help you with that if you require private collaborator setup. So the collaborator was released in 2015, so we've had a long time to make use of it within the scanner, and it's very heavily integrated into various scanning techniques. Here are just a few scan checks which use the collaborator. So there's some fairly well-known ones like SQL injection, command injection, deferred XMSS will detect with the collaborator. And I've included a couple of esoteric examples. We've got request smuggling, cache pointing. Some of those will use collaborator payloads. And then we added JWT specific scan checks early on in the year. And for these particular vulnerabilities, the collaborator was the right tool to use. So there's many, many more scan checks which use the collaborator. This is just a small sample. So obviously the scanner takes care of many details for you. And one of these is the polling associated with the collaborator use. So both within individual scan checks and then at key points within the scan itself, the scanner will poll the collaborator, retrieve any interactions relating to its own payloads, and then report the relevant issues. In addition to this, there's also background polling which goes on within Burp when it's running. This is useful for finding deferred issues, deferred interactions. So, for example, you can imagine sending some payloads on a Friday, so either manually within the manual tools in Burp or using the scanner, shut down your project file, go home for the weekend, and over the weekend, some system takes these payloads, triggers interaction with the Collaborator server. You come back on the Monday, fire up your project file, and then this background polling will start, and then we'll go off to the Collaborator, retrieve the interactions, and then in the case of the manual testing, report the relevant interactions, and in the case of the scanner, report the relevant issues. So that's a nice capability. Okay, so this is an example of an issue we've detected using the Collaborator. So this is as shown in Enterprise, although it will look somewhat similar within Pro. So this is actually the example I was talking about earlier, where we've put a Collaborator payload in a referrer header, and that's then triggered an HTTP request to that subdomain. This has actually come from a scan of our gin and juice shop, which is a intentionally vulnerable site which we run at PortSwigginar to allow people to familiarise themselves with Burp, or just to use in general. So if that's of interest to you, then feel free to use it. So with respect to issues, we always assign them both a severity and a confidence. So the severity here is shown as high. Now that's not true in general for all Collaborator detected issues. So the DNS counterpart of this would only be assigned informational severity, because there's nothing inherently insecure about DNS lookup. The confidence in this example is certain, and that is true for all Collaborator detected issues. And the reason for that is twofold. So a system has to have reached out to the Collaborator and triggered a DNS, HTTP, or SMTP interaction for there to be an issue. And also, due to the use of these one-time use identifiers, we know for certain that it was this particular instance of Burp which triggered that interaction. So what I'm getting at is the signaling we get from the Collaborator is really some of the strongest signaling we have within the scanner, and hence we report the confidence is certain. So in addition to the many scan checks which leverage the Collaborator functionality, you can also access its capability via the extender or extension API. So this is both the older iBurp extender callbacks API and the newer Montoya API. The latter actually has slightly more functionality now, which is nice to see. So many of our BAPs in our BAP store leverage this capability. So you can generate your own payloads and then poll for interactions. And this is used in a variety of ways within these BAPs. So obviously you can use these as well, and you can obviously write your own if you have some niche requirement. This is one example of a BAP which uses the Collaborators. This is an extension which looks for the log4shell vulnerability. This is nice for two reasons, really. First of all, the Collaborator was the perfect tool to detect this vulnerability, and we saw a large increase in the load on our public Collaborator server and in the number of requests for people wanting support in setting up their own private instances when the CVE went public. And also this, like I said, was a community developed extension, so it was in the BAP store within a couple of days of the CVE being made public, so people were able to very, very rapidly work out what their exposure was to this issue. So we need to start kind of wrapping up. So last slide I've got for you is this is James Kettle of the infamous RBNO Wax. This is his research from a while ago, 2017, cracking the lens, where he made heavy use of the Collaborator to get into all sorts of places where he shouldn't have. I still think it's worth checking out, and if you're interested in details, then have a look at that. It was very well received at the time, and it resulted in presentations of both Black Hats and Vegas. One thing that was nice about this work was it was just done using the public API that I just spoke about, so it was only performed using the public iBurp extender callbacks API. So there was no special access required for him. And also, as with all of James' research, we then take his ideas and we put them back into the core product. So in this case, this gave rise to the Collaborator Everywhere scan check, which is now part of the core scan checks within Burp. Okay, so that's all I've got. I hope that was of interest. I'll hand you back to Hannah now. Thank you.
Brilliant. Thank you, Rik, for the fantastic overview of Collaborator, OAST, the gin and juice shop that you mentioned. So I hope you all found that useful. If you do have any questions regarding the topics that we've discussed, please drop them in the Q&A box now. Their team is there and they'll be able to take a look at answering them for you. like I said, if we don't get around to answering them, don't worry, we will be following up after this session with anything we missed. Before we get into the overview and demo of Burp Suite Enterprise Edition, it's useful to cover how it's licensed. So I appreciate this may appear as quite a dry topic to concentrate on, but it's something we get asked on nearly every customer call. The main reason being is if you're currently using a competitor solution, our licensing model is quite unique in the sense that we charge per concurrent scan and not per application or URL. So to clarify, we don't limit you on the number of apps, domains, users, URLs, anything else, only scan concurrency. So the fact that we license Burp Suite Enterprise on scan concurrency, or the maximum number of scans you can run at one time, it makes our model extremely flexible. And it's important to note that you can actually also assign and reassign your scans across any websites, applications, and URLs. But from this, we're often asked, well, how many concurrent scans do I need if I'm not being charged per application? And in order to best determine how many a customer might require, we ask them to have a think about what number of apps do they have and how often do they need to scan them. Also, whether they have a specific window that they would like to scan in. So, for example, they may be restricted to only scan on weekends, overnight, and then finally, whether they have a specific budget in mind. But if we look at an example, so say you have 500 applications across your organization, some may be public-facing apps that have daily dev work, some may be internal apps that are stable and possibly only have work carried out every quarter. But whatever the combination, it's unlikely that you're going to need to be scanning all 500 every day. So more realistically, you may be hitting 50 apps per day, and that'll be from a combination of scheduled scans and scans triggered by your CI/CD pipeline of choice. So assuming your scan times fit into a working day, you'd only need to purchase 50 concurrent scans. And if you kicked off more scans than you had available, they would just be queued until free. So what does that look like in terms of pricing? We're incredibly transparent here at PortSwigginar. Our pricing is directly on our website, but just to inform you on this session, a Burp Suite Enterprise Edition license with one concurrent scan, which is our minimum, is $5,999. And each additional concurrent scan is $599. So based off the example I just went through, a Burp Suite Enterprise license with 50 concurrent scans would be $35,350. And that is based off a 12-month subscription. However, we do offer multi-year subscriptions for up to 10 years. So now we'll quickly touch on Burp Suite Enterprise Edition's architecture and deployment, in which I'll pass over to Alex.
Cheers, Anne. Okay, folks. So we'll just quickly go through some of the options around deployment and cover off the architecture for enterprise, and then we'll jump into the demo and show off some of the key features. So enterprise is made up of a number of core components. The first of which is the web server. So this is how the users access the product itself, but you can also access it via an API client if that's your preference. Then we'll have the enterprise server. This is essentially the business logic behind the scenes. This is what controls the enterprise installation itself. And then we'll have one or more scanning machines. These are the entities that actually perform the scans. Think of them as your automated penetration testers effectively. And then each of those components will connect to some form of SQL database. In terms of your deployment options, probably our most popular is just the standard installer. So you grab the release from our release page, deploy to an operating system of your choice. So we support Windows, different flavors of Linux, and Mac OS. Essentially, if it's 64-bit and you can run Java, you should be okay. And then we have the single machine deployment, which is just typical for POCs and trials, everything bundled into one physical or virtual machine. And then a multi-system deployment, which is typical for a production deployment. If your preference is around containerization, we also have the Kubernetes deployment available. So we provide a Helm chart for which to deploy the application, and we're trying to be as agnostic as possible in terms of the underlying architecture. So if you want to deploy to different cloud providers, that's certainly possible. And this gives you the benefit of the auto-scaling scanning machines. So with the standard installer, the architecture looks like this. We'll have the web server and enterprise server live together on their own machine, again, physical or virtual. You can go for our bundled database, but again, that's only really typical for a trial or POC. When installing to production, you would typically use your own external database, of which we support a number of different SQL databases. And then we also have our scanning machine deployed separately. So it's got dedicated resource because this is the entity that's actually performing the scans. The scanning machine will talk to the enterprise server and the configured database. And then we've got some outbound and inbound connections as well. So we see there PortSwigginar.net via port 443. This is just for license activation and for how we deliver automatic updates if that's configured. Of course, the scanning machine will want to talk to your target applications. And by default, as Rik has just given a talk on, the Burp Collaborator itself, and that can be deployed privately if desired. And then, as we mentioned already, the users or your API clients for connectivity into the system. For Kubernetes, we do have some prerequisites that you'll need to meet in terms of the cluster that we're deploying the application to. So this is going to be an ingress solution, typically a load balancer or ingress controller. We'll also need a persistent volume claim, so that's application-PVC, whatever name you give it, and that needs to be shared by all the nodes in the namespace to which we're deploying enterprise. And then for the auto-scaling scanning machines, the cluster autoscaler must also be installed and enabled. So rather than pre-provisioning those scanning machines like we would with a standard installer, every time we initiate a scan job, a scan pod is created, it'll run and then be killed off once the scan is finished. So if you are deploying to a cloud environment, that's got some inherent benefits in terms of cost. So based on those prereqs, you should be able to deploy to anything you like, AWS, Azure, GCP, or private cluster. This is kind of the responsibilities for the Kubernetes deployment split out. So you'll see everything in the Helm chart on the right-hand side. You'll provide for the ingress. That'll talk to the web server service. And then the database will sit outside that cluster as well. But we do give you scripts for which to deploy the database with the appropriate users and permissions. Okay, folks, that's it in terms of the architecture. We'll jump into the demo now. So I shall just sign in here. As you mentioned, web-based products, so we're going to access via the browser over our specified URL and port. Job number one is probably to set up our team. So Enterprise does support role-based access control. So you can create a number of users based on your requirements and split out those permissions as you see fit. So you might have someone who's just looking after and maintaining sites. Maybe someone's just initiating scans. Maybe someone's creating and extracting reports. Entirely up to you how you carve out your team's access. Everything in terms of enterprise is site-based. So these sites are our target applications. This is what we're scanning, and that's where all the configuration data is held as well. So if we jump into sites here, as a new deployment, we can import all of our existing sites en masse by completing the CSV template with kind of the critical bits of information, and then upload that, and it'll import all of our sites for us. I will give you an idea of what it looks like to create a new site. So we'll give the site a name, and then these can be distributed into folders. See on the left-hand side, we've got a structure already. This is entirely determined by the user, but it might be in a team basis, geographical location, test versus production, however you see fit. And then the important component is the site scope. So we want to give it a main site URL, and this is the highest level URL that we want to provide for the scan of the target application. And then all subdirectories of that URL will be scanned by default. That's going to be HTTP and HTTPS, unless you just want to specify one of those protocols. And if we want to configure this further, we can additionally provide some inclusive URLs. Maybe we want to call out a very specific path that we want to scan. Or if there's something we don't want to scan within the application, for whatever reason, we can exclude that URL as well. Now we get into the configuration for the scan itself. So we've got two modes in terms of what scan configuration we apply. We've got the preset scan modes, which you can see here. Everything from a lightweight scan, which is going to be capped at 15 minutes, just a quick snapshot into the application, all the way to deep, which is going to be greater in terms of the coverage for both the crawl and the audit of the application at the sacrifice of kind of the length of the scan. But you do have complete control to create your own custom configurations. So those that are familiar with Burp Suite Professional, you'll see some similar options here in terms of how we can carve out that scan configuration. And we give you some inbuilt configurations to get started with as well. And this is just about changing the behavior of our two scan phases, the crawl and the audit. So maybe we wanted to do something like a passive audit, for example, limit the crawl to a set amount of time, have a scan that's going to focus on minimizing false positives, that sort of thing. They're available out of the box. If our application needs any kind of authentication, we can configure that here at the site level as well. So just something basic like username and passwords. Anything more complex, we would use our recorded login sequence, which can record the process of us logging into our application, generate a JSON, and we can cut and paste that here. Again, a crawler would use this anytime it wants to log in. Anything more complex like SSO, multi-page login. For those pro users out there, extension support is also available in Enterprise. So these are community-generated plugins. You can take a look at the Map Store to see what's available for Enterprise. But again, this is going to modify the behavior of the crawler in some way, shape, or form. And we do have this framework available if you wanted to create your own extensions as well. Scanning pools are a way of dedicating our scanning machine resource. So we can split those out into pools. So if you have different use cases, for example, something like our ongoing scheduled scans, but also some CI/CD pipeline work, and we don't want to cross over in terms of the scans that are going over, we can separate those resources out into pools. That's it in terms of site creation. Once we've created our site, typically we would then create our scan schedule, which is going to automate our scans against that site. So if I click on New Scan, select the site from the site tree that I've created, and I can then schedule scans to commence on a particular date and time, and that'll repeat on whatever set basis I give it, either indefinitely, repeat a set number of times, or until a particular date. I can, of course, just run a one-off scan, and that'll start now. Once I initiate a scan, I can view the timeline and monitor the progress of the scan. It'll be assigned to an available scanning machine. It'll then enter the crawling phase when I can see how many requests are being made, what particular URL are we looking at that given moment in time. Once we've mapped out the application, it will move on to the auditing phase. It'll be based on the scan configuration that we've applied, and we'll start to see those issues populate. If I go into an older scan, we can see this one's completed, and then I get my completed scan view. And this is where we start to see those issues that have been populated, and we can start to dig a bit deeper into what's been located. As Rik mentioned, all of our issues are categorized. So we've got that severity level that we mentioned, and we can filter on that basis. And then we've got our confidence rating as well. Perhaps it's a false positive that we want to mark. But if we drill down into a particular path here for this cross-site scripting, we can view our advisory. This is going to give you additional information around the vulnerability, the specific path and host, background detail, remediation advice. There'll typically be a reference to our Web Security Academy, which is a free resource around security learning. So we'll get even more detail on this vulnerability cross-site scripting. There'll be the Academy labs themselves, which are sandbox environments where we can carry out the same kind of attacks. And then our vulnerability classification, CWEs. We can view the request and the response for the specific payload. But if after further investigation we determine that this is a false positive, maybe even with some manual investigation from Burp Suite Pro, we can mark it as such. And if we don't want this appearing for future scans, we can propagate that to the site or the specific path that it's been located at as well. For those that have any interest in tracking issues via ticket integration, you can see here we've got Jira integration configured, and we've got others available as well. This can either be manual, so I would select the issue and raise a Jira ticket to my specific project, or you can configure automated ticket creation as well, based on that severity level and confidence that we mentioned earlier. So I set a threshold for when I want tickets to be created, and I can automate that based off my scans. If I've got an interest in reporting as well, I can access that through the scan screen. So either a summary or detailed report can be generated in HTML format. That's going to collate together all of my results. So get some scan stats, all of the issues that have been found, and that's going to be broken down into those individual advisories that we saw earlier. I also have the option for compliance reports. So this is a fairly recent addition to Enterprise. So we started out with OWASP top 10 and PCI DSS. with a plan to add more compliance reporting in the future. And very shortly, in our next release, in fact, we're going to add Burp XML reports to this generation as well. So you've got an interest in generating reports and importing them into other systems for vulnerability aggregation, monitoring, etc. That's going to be supported for enterprise in our next release. So that's kind of our 101 of scanning, setting up sites and getting our schedule up and running. We'll just jump into the integrations page. As you mentioned, we've got the Jira issue tracking, also got GitLab and Trello. Slack is available if we want notifications for scan progress, scan starting, scans ending, etc., etc. And for those that don't necessarily want to manage users locally with the role-based access control that we looked at earlier, you can see we've got SAML and LDAP integration to pass across any existing user groups that you might want. You can then inherit the permissions that we've set and also skim if you've got that module enabled for SAML. We'll just touch on one last integration, which is CI/CD scanning. I'm going to use the example of Jenkins. But with the use of our driver, you can also perform your enterprise scans within your pipelines. So I'm going to give the example of a site-driven scan. I'll just log in here. If we go to configure, so in this example, by adding the driver, we get some additional build steps available within Jenkins, the site-driven scan and the burp scan. So I can add this step to any of my pipelines. And what we're doing here is connecting back to our enterprise server instance. So we've got the URL and the API key for authentication, which is generated from an API user we've made in enterprise. With the driver installed, we'll get access to our list of sites, our site tree, and we can select which site we want to target as part of this build. And then we determine when we want the build to fail based on the severities that we're discovering during the scan. So severity and confidence can be set. We can permit a certain number of issues if we've got a certain threshold. And then once that's all configured, we can save. Anytime that's built, we'll get an API generated scan request back to enterprise. So if we jump into enterprise here in our scan list, we can see that that's been received. And then Jenkins, through the use of the driver, will be able to monitor that scan based on the results we get. We can fail the build if required, and we can monitor it in the console. Okay, folks, that's it in terms of the demo. I shall now pass you back to Hannah.
Brilliant, thank you, Alex, for a fantastic demo of Burp Suite Enterprise Edition. Hope you all found that useful. And now we'll be rounding this session off with a quick glimpse as to what is left for our 2022 roadmap. So our roadmap is made public on our website. There's a great blog post that documents all of our roadmap items that have been added and are a work in progress for both Burp Enterprise Pro and Scanner. However, I've picked out a few things from our Burp Enterprise roadmap that I know some of our customers will be interested in. So first up, we have CI/CD inversion of control. So this will enable users to start a Burp Suite Enterprise scanner machine in a container controlled by a CI system. So this will make it possible to run scans from within temporary environments, which were not previously accessible by Enterprise Edition scanner machines. And this will essentially hopefully help people save on infrastructure costs. In addition to our current methods of billing, we will be enabling users to pay for Burp Suite Enterprise Edition scans as and when they use them. So that's further simplifying the process of scanning web portfolios at scale. At present, we have the HTML export capability, which you'll have just seen on the demo that Alex has just run us through. And he also mentioned that we will be enabling users to export scan results as Burp XML. Which enables easier integration with systems such as Defect Dojo and other vulnerability management tools. And then finally, we'll be providing templates containing reference stack implementations for deployments of Burp Suite Enterprise on a managed Kubernetes cluster. So that's on either GCP or Azure. And for most users, this will greatly simplify the process of deploying Enterprise Edition to these services. And Alex, if you could just maybe click the final one and skip to the last page. We just wanted to thank you all so much for joining us today. As you can see, there's two very short questions we have We'd love to hear your answers on them. Your feedback is invaluable. Our next session will be in December, so please keep your eyes peeled on PortSwigginar socials and our website for the next date. We will be following up with a recording of today's session and answers to any questions we may have missed. But thank you all again. Look forward to seeing you all soon, and I hope you found this session useful.
Thanks all.
Thanks, everyone.